All right. Let's start with the three little topics that we are going to cover today. Enumerations, autoboxing, and annotations. Right. So, what enumerations are? Some people call it enumerations. Some call it enumeration, right? It could be different types of pronunciation, but it's basically it's a simple concept. An enumeration is a list of named constants. A list of named constants. So what is a constant first? A constant in its definition is something that that would not change, right? So it's kind of a predefined thing. Say for example, in math you have pi, right? So you say when talking about a circle's area, you say 2 pi r, 5r squared, right? So that phi is a constant, right? So its value is not going to be changed. It's a constant thing. So just like that, here we have a example here of enum apple, right? So basically, this is talking about the different types of apples in the world, right? They have like chosen only 5 apple types. So one is called Jonathan and Golden Dale, Red Dale, Winesap and Cortland. So these are different types of apples. So the names of these will not change, right? If you take about mango, you will have a similar concept like that, right? You will have Karita Colombo and these but mango, different types of mango. So just like that, if something is kind of defined, we will use those types of definitions we can represent in an enumeration, right? So the identifier Jonathan, Golden Dale, and so on are called enumeration constants, right? Whatever you provide for these values, we call it enumeration constants, right? Each is implicitly declared as a public, static, final member of Apple, right? These constants are also called self-typed. So basically, see, when we talk about Java, right? So if we want to like represent somebody's age, we would definitely first of all give the type of variable, right? The type of the member that we want to invoke. So basically, I would say int age equal something, right? So that's how we do that, right? So, but in this case, so when we talk about the enumeration, so here we don't actually specify a data type, right? So if you look at it, it shows like, okay, Apple is somewhat similar to a class definition, just like what we declare as a class, say for example, public class Apple, right? And inside that we would have some members, right? So that's Jonathan is it's kind of like string, right? And Golden Dale, so these are all like strings. But when it comes to enumeration, they are self-typed. That means they don't actually have a different data type like string or int or double or float like that. They are like self-typed. So the type of Jonathan is actually Jonathan, right? So here is an example. So if you say okay, here we have the definition of an enumeration for Apple, and we have these different types separated by commas. And on the main method, actually we can create an Apple type here, Apple AP. So AP is of type Apple. What is an Apple? Apple is an enum, right? And we can initialize this variable AP is equal to apple.reddel. Right now, the AP takes the value of apple.reddel. So that's a reddel type of apple. And here there's an if statement which asks for whether AP is equal to apple.reddel. So it is actually checking here for equality. AP is equal to apple.reddel. Okay. So in this case, it will be basically here we are assigning it, because of that this will be true and it will print this, right? And similarly we could use a switch case statement as well. So if you remember, switch takes an input like this, right? So this value, the AP value, this AP value will be checked against each of these case, right? So in our case, AP is actually now this guy, which is apple.reddel, so it's reddel type, and it comes here and check against Jonathan. It will not match. It will come to Goldendale, not match. It comes to reddel, it matches, and then system out println and red delicious is red. All right, so that will be printed, and it breaks out of the switch statement, right? So this is basically, it's a convenient way of providing different types of something, right? Here it's like apples, different types of apples. So in our case, say for example, if it is a system that we are building or developing for a company, the company might have different types of employees, right? Employees might be like, say for example, if you divide them on the different types of employees, you could say, okay, senior managers, CEO, right? You can say middle level managers, and then leaf employees. So you can have different types of employees. Even employees can be like divided into, say for example, full-time employees and part-time employees. So there are two different types of employees, right? So in our case, instead of Apple, it would be like employee type, and then here we would have full-time employee, here we would have part-time employee, right? So these are like the examples that we can use, where we can use enums, right? So if you like look at this one, we can actually say Apple. So that's an enum, right? Enum Apple will have different values. So instead of Apple, what I would say is, let's say for example, employee type, right? We have only two employee types. One is full-time, other one is part-time, right? Actually we could have a class as well. Say for example, public class employee, right? So this guy would have a name. We could have a private name, but for the simplicity sake, I would do a public string name and the type of the employee. So I would say employee type and type. right? So I would say this also public, right? So in our main method, we could actually create an employee. So employee, so Shiham is an employee. I would say employee, new employee, right? So if you actually want a constructor, you can have that here, right? So basically, while you are creating the employee instance, you can actually pass in the name and the type also, if you want, right? But I'm going to do it a separate thing. I would assign it from outside, right? And Shiham's employee type is, say, for example, part-time, right? So he's an employee type dot part-time. So I'm a part-time employee, say, for example, right? So just like that, you could have many employees, right? So there could be another employee who is Hassan, and Hassan could be a full-time employee. So Hassan, he is a full-time employee, right? So this is actually the use case of enumeration, right? You could basically take this class into a separate separate class itself, right? And employee type into a separate class. For example, you can do a new Java class, and this is employee, right? And you can just cut this out, put it in here. Okay, and employee type also you can just copy that name, create a Java class, right? And put this enum there. Right? So now this is this should build, right? It's working actually, but we don't see anything. We'll just do an s out and do a println then to say whether this is working. This is working, right? So if I do the run here, okay, see, it is hitting this line. It is hitting this line means it's actually all of these upper code should be working, right? And say, for example, if I want to check whether I am Shiham is an employee is of okay, the type is equal to employee type dot full time. Oh, actually my type was part time, so part time I could say, right? I could say Shiham is a part-time employee. Right? So these type of things you can do. Basically, you will have use cases or scenarios that you will have to use this, right? So what you have to remember is these enums, enumeration, you will need it whenever you know, okay, there are different types of something and those types will not change, right? So employee types, full-time and part-time is not going to change, right? There is always going to be full-time employees and there is always going to be part-time employees. Just like that, there are some definitions in the world that will not change, that you can use as enumerations. So what this gives is, it's a, you know, it gives the simplicity when you are coding. Okay, so basically it's self-typed. So that's about enumeration, and enumeration has two methods in it. One is called values and the other one is called value of, right? All enumerations automatically contain two predefined methods. One is called values and the other one is value of. The values method returns an array that contains a list of the enumeration constants. So, and the value of method returns the enumeration constant whose value corresponds to the string passed in. So we will take a look at this example here. Right. So here we have the apple definition, enumeration definition. In the main method, we are declaring an apple, and then we do a println, and here are all apple constants. So this is where they have used apple.values, right? So we have two functions, so two methods. One is values and the other one is value of this one. Okay, so take a focus on this one, apple.values. So if you call this, what it will give is each of these values there are in the enumeration. Okay, so this will return Jonathan, Golden Dell, Red Dell, Wine. So all of those values, right? What returns is of type apple. So it's basically a an array of apple types, right? So here, how do you say it's an array? See, there's a bracket, right? And to loop through each of these, we are using a for each loop actually. So here is a for each loop. What you say is for apple A in all apples, right? Print the apple basically. So print this one, right? So what this for loop will do is, it will print Jonathan. So that's the first one, Golden Dell, second one, right? In order, right? Up to this point. And so that's about values. And here is the value of, right? So value of means, if you know Golden Dell as a string, right? If you pass in apple.value of, and so here in this example it's used winesap. So in that case, if you pass this one, what comes out is an apple type. Okay, not a string. It's a you know, enumeration type, right? See here, AP is of type what? It's an apple, right? Apple is what? It's the enumeration. So what comes out of this is a enumeration, and we can print it out like this, right? So in our case, we can look at the employee type for an example, right? Here in our enumeration, if you go to the employee type, full-time, part-time, and let's say we have none or no type. Okay, so we have three types here. In the main Java, let's forget about this stuff. I'll just take some spacing here and just make it a bit small, right? Maybe get rid of this. All right. So what we need to do is to iterate through this. So iterating means going through this, right? Going through this and print out each of these type, right? So that's my purpose. what do I need to do? Iterate through the employee types, right? How do I do that? Is not Apple. I should be using employee type, right? Here I would say type. So this is my variable and it's an array, and I would say employee type dot values, right? If you see here, hover over this. So what you actually get is a array of type, right? So this is actually this and that, right? All three items will return back as an array. So how to print that thing is using a for each loop, right? So that's for, and you should give the array type, the data type, which is employee type T in types, right? So just take this here, and you can actually do a S out here, right? Type is T. Right? If you just run this, see what you get is type full time, type part time, and type no type, right? So we are getting all of these three. So basically, this is what we need to highlight. The enumeration has a method called types. Values, right? Which will give the values of that enumeration. So if you had like 100 things within this, it would give all those 100 items as an array. Okay, all those 100 items will come back as an array and stored in types array, right? So that's about values. And if we want to specifically get part-time type out, right? So I would say, okay, employee, what is coming out is an employee type, right? So I would say employee type and part-time employee, let's say PT, right, is equal to I would say employee type dot value of, right, and say part time. So what comes out is actually, so here we are giving part time. This will go, and in the employee type it will match this this value and return that. Okay, so what we are getting is an employee type here, which is of part time. So if I do a S out again, system out println, the type is a part-time employee, which is that, right? So you can run it here. So we are getting these three things from this for each loop, and here the last one is this one, right? So basically we are getting a part-time employee. So what will happen if we, for the value of, if we give something that is not available in the employee type, right? Say for example, we don't have part-time SS, right? But I'm asking for an SS here. What do you think will happen? Just put it in the comments now. Are you all there? I just saw this comment. Okay, I think next time I would do that. Turn it to theme, right theme. Okay, what is the answer? So I asked, if I do this employee type dot value of and ask for a part-time SS which is not available here, what would I get? So basically just comment this out. We don't need this. We don't need that. Right? I'm talking about this line. And then what will be the output? Still no answer. Okay, let's run. All right, so this is what I'm getting. What is this actually? We looked at this last week, but different types of exceptions. So here is another exception type here. Right? It says illegal argument exception, and the description is no enum constant employee type dot part-time SS at Java base lang enum dot value of. So it actually could not find in employee type this particular value. Okay, so it's throwing an exception. So if we wanted to, like, have a try catch here, and if we don't want this to error out or bombard, we could do a try catch here and do an exception ex and say s out. I could say there was an exception. That's all. Right, so basically this will all right, so what this will do is, so we know on this line it will like jump out an exception, right, and it will come here, it will be caught by this this catch block, and it will print this out, right? So that's what should happen. So if you see, that is what is happening, right? There was an exception, but this is my message, developer's message. It's not the exception bombarding out, right? And if you wanted, you can actually print the exception as well here. So if you say ex and run, see, there was an exception, so that is my message, and then the exception is Java lang illegal argument exception, right? So if you want, instead of general exception, you could use this one, illegal argument exception. So actually you can specifically catch that type of exception, illegal argument exception. Okay, so that is also possible. So if you do this, you will get the same thing actually, right? But if you catch a different type of exception, say for example, if you do a null point exception here, you are actually catching only the null point exception, right? So run it. In that case, what you get is this red thingy, right? Because on line 17, it will ask for the value of part-time SS, which is not there in the employee type enumeration. So we will have an exception here. But what is coming out is a illegal argument exception. But what we are catching is a null point exception. Because of that, it can't catch that type of exception. It will not come here. And since there are no other catches, it will just break out, right? So for a precaution, you could actually have a general type of exception catching here, right? This exception means it's a generic thing. So if it does not match here, it will come and check for this as well, right? So in that case, I am at generic catch. Right? So if you run this, see, I am a generic catch because I am asking for null pointer. If this was an illegal argument exception, I would come here, right? Okay, there was an exception here because what is coming out is an illegal argument exception. So that's about enumerations basically, right? So you should have got an understanding now about enumerations. We use them whenever we have some constants and different types of things that we know it is not going to change. Employee type is an example. Apple types, example. Mango types, example, right? Student types, maybe. That's also example. Virtual student, physical student, right? Student types, example. Bit students, AAT students, CMA student, right? And gender, example. Male, female. So these are things like, say for example, there are many examples that you can think of, right? And in terms of student types, you can say on-time submitting students, late submitting students, lazy students. So just like that, you can like categorize, right? So here in this case, we are. I think it's clear about the enumerations. Can you all just tell me whether it's clear or you need more explanation? Yep. And then let's move on to the second small topic, which is type wrappers. Type wrappers, right? Type in sense we are talking about the data types here in Java. You know there are different data types, right? So here it's basically, if you see in Java we have these two types of things. So I have cleaned this up. So we have a main method and here is the completion. So here whenever we need to like for example, if I want to represent age, and we know int is a primitive type in Java, right, which is 32 bits. Okay, it's memory space taken for a Java variable, which is a integer, is a 32-bit space, right? And just like that, we have string, we have double, right? Double price, for example, 230 rupees, right? So there are different types of primitive types in Java, and here today's the second topic is type wrappers. So that is basically wrapping the primitive types in an object. So say for example, for double normally we would use a simple double, right? For float we would use a simple float. For integers we would use just int, simple int. For short, simple short. So those are primitive types, and their equivalent type wrappers or the objects are these capitalized ones. So in this example here, just have a good look at this example. So we have a class. Within that class we have the main method. On the first line, integer. Okay, so that's basically type definition, integer, and here is the variable integer is equal to new integer. So what does new do normally? It creates an object of the class, right? So here this means what this actually means is this line, it is creating an integer type object, and we are passing in the value 100. Right? So this integer will have the value 100 inside it. Okay, and so if you do this one, which is system out println value is integer dot int value, what we would get out is 100 which we set. Okay, so here you see the output. So actually, why do we need to do this? We already have an int, right? Simple int, and why do we need a type wrapper for this? Anybody has any answers? Okay, so the answer is actually, if you wrap in a object or a class, you can actually control the values in it, right? So basically I am setting 100 here, right? Here if you see this usage, it is telling, okay, integer dot int value. What that implies is you can pass in a value as an integer, which is 100, right? And taking out as an integer. And similarly, you could have a different method which would return a byte value out of integer. You can have another method which will return a double value of the integer, because there are, as we know, number types can be assigned to different data types, right? So basically integer can be assigned to a double, integer can be assigned to a long value, right? So if the types are compatible, we can actually change the data type or assign to different matching data types, right? And we could do a convert into a string value of the number representation. So these things we can do actually when we have a type wrapper or a class that is wrapping our specific values, right? In this case it's integer. So just like that, you have type wrappers for double type, float type, long types, all these types, right? So we will quickly talk about something called autoboxing, right? So here so our example would be integer, right? Integer val is equal to new integer, and we could give 300. right? And then we can use val dot. See, what you see is these are like different types of things that you can do on integers, right? So here what you see is byte value. So basically I can convert this to a byte value also, right? So if this is 100 and if I run this, see what I get is 100, right? So for a byte value, you know how many bits that is that a byte consumes, right? How many bits? For a byte, how many bits are there? It's a question. Yeah, a byte has 8 bits, right? So for 8-bit, actually I have discussed this. How many? So what is the range of a byte? Right. So it should have a from something from a negative to positive something, right? So negative value to a positive value. What is the positive value? Negative value and the positive value range. Right. That's -128 to +127, right? So here in our case, I am passing 100, which is a valid value, right? So if I go past this 127, for example, if I do 130, right, this conversion will be an error. If you see here, okay, so I am passing in 130, but what I get is -126, which is not valid, right? Because I am passing 130. I am expecting 130 to come here, but what is coming out is -126. So this is where you need to look at about a subject topic called 2's complement. So what computer uses is 2's complement for this, and what happens in a data loss. So data loss means from 8 bytes, so 8 bits, we should represent 130 in 8 bits. So you can do the conversion in binary and see what happens. Okay, and you can check against this value. Okay, is this the real value that comes out? All right. So this is about type wrappers. Basically, type wrappers are the object wrappers around primitive types, simply. Right. So let's move on to the slides. So let's take a look at autoboxing. So this is another it's a fancy name for a simple thing. So what autoboxing is? Autoboxing is the process by which a primitive type is automatically encapsulated into its equivalent type wrapper. So autoboxing means, you can, from the name you can imply, you can infer a primitive type becomes boxed by a type wrapper. Okay, so that is autoboxing. A primitive type, say for example int 8, simple int 8 becomes the integer capital INTG. So that's the equivalent type wrapper object, right? So here is an example. I am telling obj is of type this class, okay, which is integer class, and I am providing 100, right? 100 is just a primitive value. But once you do this, what happens is this value just goes into this integer class and stored in object. So now what we have is actually the type wrapper object, not the primitive value, right? So this is called autoboxing. So you can just think of it as you are wrapping the value with a container or a box, right? So that box is basically the type wrapper, right? You just like the gift wrapper, just like this is a type wrapper, right? And the reverse of it is called auto unboxing. So basically from the wrapped container you are taking the value out, right? So auto boxing is the process by which the value of a boxed object is automatically extracted. So extracting, we call that unboxing, and from a type wrapper when its value is needed. So here is an example. So this obj is actually this one, right? So which is the integer type wrapped object. And if you just assign it to a primitive I variable, this will be automatically unboxed. Okay, so what you get out is actually this 100 only, not other things like the dot int value, dot short. So those methods and some other utility functions in this class will not be there. What will be there is only the value inside, right, which is 100. So this is called auto unboxing. Okay, so auto boxing wrapping occurs when work with methods, expressions, switch statements. So these are like different examples of it, how we have the boxing, right? Here is a method. So method's name is simple M. Okay, it denotes the method, and it takes an argument or a parameter of integer wrapper type, and this is the variable name for that, right? So how we can use that is simply, basically you can say M and just pass in the value, right? You don't have to pass an object of integer, an instance of integer. You don't have to pass. If you pass just the value also, it will just do the auto boxing automatically, right? Because here in this place what is expected is an integer class. Okay, I'll just demo it in the code as well. So here is another place, right? This is same as this one. So this is auto boxing, and here in the switch statement also it's the same thing. Here this is unboxing actually, right? So we are passing in an object is actually type wrapped one, and what we are checking against is a primitive type, right? So this is boxed version. When it comes to the matching, it will automatically unbox and match it with the value. Okay, so here are some examples. All right, so here integer is the wrapped type, basically it's the box, and assigning 100 means this 100 goes into the box. So that is auto boxing. When we want to take out from IOB this wrapped objects, we do this, right? So I will get the value 100 and it is being printed, right? So this is auto boxing, this is auto unboxing. Okay, and here auto boxing unboxing helps prevent errors. So here say for example integer. So this is an auto boxing example, right? IOB integer can have value 1000, right? It's a valid in the range. And on the next line, what we are trying is actually IOB dot byte value. So 1000 is actually out of range, right? It's greater than plus 127. So because of that, we know there should be a problem, right? What is coming out is it's not a good value, definitely a valid value, and then we are printing it out. So this is what comes out. Okay, so after this auto boxing and unboxing helps prevent errors as well, because we can say we can expect the range that comes out of it, right? So basically, if you want to have a go at it, you can do it like this. So this is called Autoboxing. That's an Autoboxing example, right? Value has been passed to a class object, which is val, right? So this is Autoboxing. So when we take it out, say for example, int I, if I do this, this is auto unboxing, because from an object wrapped one, we are taking out the value and put it in a primitive I variable, right? So this is called auto unboxing. Right? And you can actually print out and see the value. Right? Is there any question up to now? Any doubts? Anybody can just tell. Okay. Is it clear? Yep. So on change in the theme, say, I mean, okay, for a fact, at the moment, I don't know how to change the theme in what IntelliJ IDEA, right? So what I would do is go here, how to change theme in IntelliJ IDEA, right? So it is telling, okay, press Ctrl Alt S, select appearance and behavior, select UI theme from the theme list, IntelliJ Lite. Okay, let's do that. So this is how I would do. This is normally how software engineers work. Control Alt S, Control Alt S. You can also do that. And go to appearance. So I'm at appearance and theme. And I have two themes here. One is IntelliJ. Okay. And apply. Okay. So that's how to change the theme. Right? Is it better, Asma, now? But I like the dark one. Anyway, okay, so that's how you change the theme for a fact. Right, let's look at something else called annotations. Right. So we for today, what we have looked at is one thing is the type wrappers. The first thing we looked at was enumerations, right? And this is the third thing, which and the final thing that we are going to look at today is annotations, right? It's a simple two slide thingy. It's no rocket science here. So what are annotations? Annotation enables you to embed supplemental information into a source file. So source file is our Java file. Basically, this file is a source file, right? So main.java is a source file. Employee type, this is a source file, and this is also a source file. Okay, so what annotation is, so basically if you search for in web what is an annotation. See, it is actually annotations are used in order to add notes or more information about a topic, right? So basically it's telling more information about something, right? And an annotation is an extra information associated with a particular point in a document. So if you take a document, you will have annotations, right? So basically little descriptions or elaborations of some stuff, okay, for more clarity. So it's similar in Java. Annotations enables you to embed supplemental information. Supplemental means extra information into a source file. It's like a programmatic documentation, right? Programmatic documentation. So how we do annotate is using a symbol called at that precedes the keyword interface. So there are some built-in annotations as well. If you can remember, okay, I'll just do an example here. So I would introduce a interface here, right? So that's let's say base employee. I would just prefix it with an I, capital I. Okay, so that's an interface actually. It's not a class. Okay, and here I would say void pay salary. Right. So what this would do is, say for example, if I want to say give the salary amount as well, I would say like this, right? So in the employee class, all of the employees have to have a pay salary method. Okay, so to do that, what I would do is tell here implements ibase employee. Okay, so to implement ibase employee, ibase employee has this method, right? Pay salary. So I will have to come here and do this thing, implements methods, and click on this, right? And okay. See here, what you are, what you are getting is an annotation at override, right? This is basically telling, okay, you are implementing the I interface, ibase employee, right? Which has the definition, or it's not definition actually. Yeah, it's a definition which is pay salary, right? It's just like a contract. You are telling, okay, all the employees should have a pay salary method. Okay, and when it comes to the concrete class, which is employee, you are giving it a body, right? So this would be like I would do just an S out here, paying salary, right, amount. Okay, so in our main Java, we could actually create the employee here. All right, employee Shiham is equal to new employee, right? And I can pay the salary to him. Let's give a 500,000. And if you run that, okay, so what you get is this one. So basically, what I wanted to demonstrate here is in the employee class, you have at override, right? So at means it's basically giving more information about the method here. So basically this is telling, okay, this space salary is actually defined in somewhere else, which is the interface, and I am overriding it, right? So that's more, it's kind of extra information that is giving, right? So what happens if you don't have this? You don't have that at override, okay? And if I run this, I am still getting this. There is no error. Okay, I'm still getting this. There is no error. Why is that? Because these annotations, they are not mandatory. Okay, so they are basically there to say more information about something, right? So annotations are, it's not mandatory. It's just basically giving more information about something, and that is why we have something called annotations. Okay, so these are different ways, different things that we can use in Java. So there is annotation called retention, at documented, target, inherited, override, deprecated, safe var args, suppress warnings, right? There are different annotations that you can tell, and actually that's about annotations. So here is another example, right? So here it's basically, this is an interface, right? On the go, you can actually tell, okay, this is an interface called release, right? So there are some like programs that we can run to generate documentation of the source code. So if I want to repeat that again, there are some tools that we can run to automatically create the documentations of your source code. So if you have like good commenting, say for example Java, there's something called Java document comments. If you use those commenting practices, you can actually create a a guide, developer guide, uh, on top of your code base, and the new developers who comes in, they will have a way to understand the existing code. So that the annotation is almost always about the documentation or giving more information about the source code. Okay, so here is another example, which is at release. We are telling, okay, version is this, developed by some developer and tested by some tester, right? So this is giving information about student app, who developed it, who tested it, what is the version. If tomorrow Asluf comes in and he wants to make this a version 2, you would say version 2.0 developed by Asluf and tested by the tester, right? So this is one example of it, and I think for today we can these are all things that I wanted to discuss. If you have any questions, shoot me. I'll try to answer. Any questions? Only Shafia is typing. How about others? Yeah. Yeah, any other question? So deprecated, you know the meaning of deprecated, right? Basically deprecated means you are no longer using it, right? Say for example, okay, this is my program, right? So this is my system and I have an employee type and main, okay? And for some reason I have another pay salary method here, public. So in version 1 I had this pay salary method, okay? In version 2 I am introducing a different pay salary method, public void pay salary, right? But I don't have any arguments here, arguments in the sense no parameters. So I'm gonna just control C it and control V it here. So I will not be giving the amount here. Instead, I have the salary here somewhere, public int salary, for example, and I have that value here, for example, right? So if that is the case, I would use my salary from here, this dot salary, right? So the reasoning behind these two things is, on the first version I had this this functionality working, that's fine. When the system moved on for a period of time, I understood, okay, this amount should not come from out, and I should use this one, okay? But already some of the people are using this, what I have released, okay? So what I now want to say is, okay, I don't want you all to use this deprecated. I want to use this one, okay? So deprecated means I am just telling this is there, this functionality is there, but don't use it, because in a future version I will be removing it, right? In a future version I will be removing this pay salary, so because of that don't use it, right? So that is basically it. Deprecated is used as a way of telling we will not be using this in the future, okay? I hope it's clear. Any other questions? And I was able to tell that because I knew that. If you don't know anything about this, for example, if you don't know about what at documented is, so it's a simple thing, right? At documented annotation Java, right? Go there. Maybe a Stack Overflow answer is a good answer. Go there. What's the purpose of at documented annotation in Java, right? So there will be some smart guy who have like answered this. Just go to the answers, the ticked ones, and look at it. At documented is a meta annotation. You apply at documented when defining an annotation to ensure that classes using your annotation shows this in their generated Java doc. So as I mentioned, there is a way to generate the documentation automatically, right? So when you do that, this will do something. Here is an example, right? So there's something called target method type retention inherited. So it is basically inherited and it is also documented. So if something is documented, it will be included in the Java doc. So that's what it's telling, okay? So just like that, you can basically, if there is more information that you need in any of these slides, you can basically go and search for stuff, okay? Even at deprecated, you can actually come here and search for that. right? You will get a better, explanations there. So looking at this, a deprecated annotation indicates that the marked element is deprecated and should no longer be used. Understand? So the compiler generates a warning whenever a program uses this method. It could be a method, it could be a class or field, anything. Okay. All right. So that's about it. And let's wrap it up. With that, let's say goodbye and have a good day.